Hi guys, this is your second video lecture for the week. We will be covering section 8.2. With that, we have completed chapter 8 for this course. So on Friday, after we have our live session, to make sure we're all caught up, to give you an opportunity to ask any questions you may have about the topics that we've discussed in chapter 8. The test will go live after we're done with our live session, and you'll have 2 hours to take it like we did last week when we took the test for chapter 7. All right, so without any further ado, let's go ahead and move into the lecture for today. So I'm going to start sharing my screen here with you. And here we go. And there we go. So that we can take a closer look at these notes. And I'm going to zoom this in for you a little bit. There we go. That's a little bit better. All right, guys. So for section 8.2, we're going to pick up where we left off, having our conversation about integers, which is basically how we discuss positive and negative numbers. And we also, if you recall, in section 8.1, discussed how to add and subtract them, the rules and regulations behind how to work with positive and negative numbers. We used a model approach as well as a number line approach to sort of give you some concrete visual ways of learning how to deal with addition and subtraction of positive and negative numbers. We're going to do the same thing today as we discuss both multiplication and division of positive and negative numbers, as well as how to order them, i.e. meaning how to compare them, which one's greater, which one's lesser. So let's begin by talking about multiplication and its properties. Like addition, there are some properties that are in effect when we're using the operation of multiplication, and they do apply specifically when we are multiplying with positive and negative numbers or with integers. So we are going to talk about some of these properties, but there are a couple of rules to how we are allowed to multiply with positive and negative numbers. The rules can be broken down into two basic rules like we did with addition, but I'm going to start this time by actually walking you through some of the specifics, and then I'll go ahead and give you the two basic rules that you can apply when multiplying with integers, okay? So first of all, the definition of how we multiply with integers is the following. We let A and B represent integers, meaning any positive or negative numbers, and then the following rules apply and are true. Rule number one, that multiplying by 0 is still the same as when multiplying whole numbers by 0. Any integer multiplied by 0, the product of which will still be 0. So whether we use integer a multiplied by 0, we still have 0 as our product. If we multiply b by 0, we still have 0 as our product. So multiplying by 0 still applies with integers as it did with whole numbers. Okay? The second rule that we follow when multiplying with integers is that if a and b are once again positive integers, in this case they're both positive integers, then when we multiply a and b, their product, c, will also be a positive integer. Or another way to think about it is that both positive integers, this is what happens when they're both positive integers. If they're both positive integers, their product will also be positive. Okay? If we move on to what if a is a positive integer, but b is a negative integer? What is the rule that applies here for when one is positive and one is negative? The rule is that if a is positive and b is negative and we multiply them together, their product, c, will be a negative integer. So when multiplying a positive integer by a negative integer, their product, c, will be a negative integer. Okay, so that is the rule of what happens when one integer is positive and one is negative. So far, just as a quick recap, we have discussed what happens when we multiply by 0, and that has stayed the same as when we multiply with whole numbers. Now we're getting into some integer specific rules about multiplication, and that is when both integers are positive, we get a positive answer as our product. When one integer is positive and the other is negative, we get a negative product. And finally, what happens if both integers are negative? It's the only scenario left, right? If both integers are negative, this is scenario number 4 or rule number 4. If both integers are negative, then the product of those integers is positive. Surprise turnout here, right? So if both integers are negative, then their product, C, will be positive. One more time to recap, because these are rules important to be able to be remembered and understood. Multiplying by 0, same rules apply as when multiplying with whole numbers, as when you're multiplying with integers, positive and negative numbers. When multiplying two integers that are both positive, our product will also be positive. When multiplying two integers where one is positive and one is negative, this is scenario number 3, our product will be negative. And finally, scenario number 4, when multiplying two integers where they're both negative integers, our product will be positive. Let's look at some actual concrete examples reflecting these same 4 scenarios. So scenario number 1 was where we were applying the multiplying by 0 rule. And sure enough, a negative integer, -1 times 0, our product is still 0. And a positive integer, +2 times 0, our product still 0. So as expected, our multiplying by 0 rule of multiplication still applies even when multiplying with integers. Rule number 2 was what to do when both of our integers are positive. Well, that's like multiplying whole numbers as we've always been accustomed to it, right? No difference there. 1 is positive, 2 is positive. 1 times 2 is 2, as we would expect it to be because we've been dealing with whole numbers until this point. 3 is positive, 5 is positive. 3 times 5 is 15. Again, as we expect to happen. So when both integers are positive, we're basically looking at the multiplication of numbers, whole numbers, as we've always been accustomed to doing. Scenario number 3 is what happens when one integer is positive and one integer is negative. In this scenario, we have a -1 being multiplied by a +2. A -1 being multiplied by a +2 gives us the product of -2. So the rule here was if one is negative and one is positive, our answer will be negative. But please note that the multiplication itself is as we would expect it. 1 times 2 is 2, okay? All that we've taken into account here is because one was negative and one was positive, our answer was also negative, as per the rule that we discussed in scenario 3 as applying multiplication to integers. Rule number 4, or scenario number 4, is when both of the integers that we're multiplying together are both negative. As we see here in this example, we have a -1 times a -2, and our answer is a +2. Again, please note that the multiplying itself is the same as when we multiply with whole numbers. We would expect that a 1 times a 2 would give us a 2. But the rule that is applying here, because we're dealing with integers, is that because one is negative and so is the other, then their answer is positive. You can see it again at work with -3 times -5. We would expect that 3 times 5 is 15, but the rule says that if they're both negative integers, as we see here with a -3 and a -5, then the answer or the product will be positive. Now, what this all boils down to is the following. It all boils down to these 2 basic rules that apply both to multiplication and division. So I'll repeat that again. These basic rules apply to multiplication and division, not addition. That's why we began our conversation about integers with addition and the rules that are specifically applied to the addition of integers and how we deal with subtraction when dealing with integers. So these rules that we have just discussed today apply only when multiplying and dividing integers. And the rules that I just mentioned to you here, rules 1 through 4, can be boiled down to: if they have the same sign, your product will always be positive. If they have the same sign, your quotient will always be positive. i.e., they're both positive, your quotient will be positive. They're both positive, your product will be positive. They're both negative, then your quotient is positive. They're both negative, and your product is positive. Okay, so when the signs are the same, your answer will always be positive when dealing with integers. And then when the signs are different, meaning we have one positive, one negative, if we're multiplying a positive and a negative, we will get a negative answer. If we're dividing a positive and a negative, we will get a negative answer. So all these rules boil down to the following. If the signs are the same, our answers will always be positive, whether product or quotient. If the signs are different, our answers will always be negative, whether product or quotient. Okay? Now, if we move on, we said we would discuss some properties of multiplication, so here they are. A lot of these properties we've already talked about when discussing fractions, we talked about when discussing decimals, and we even talked about when discussing addition, and you will notice that some of those same properties are still in play even as we discuss multiplication of integers. Please note that, again, we are specifically referring to multiplication because as in addition and subtraction, the properties that apply to addition do not all apply to subtraction, and the same is true. The properties that apply to multiplication do not all apply to division. So we're going to talk about these properties in the context of multiplying integers, okay? Once again, the closure property is in effect. What does this mean? It means that if A and B are both integers and we multiply them together, then their product will also be an integer. Something that we kind of all know intuitively because of the basic math skills that we've picked up along the way, right? So 1 times 2 will be 2. 1 is an integer, 2 is an integer, and their product is also an integer, okay? We also have the commutative property, which states that if A and B are integers, then their order, whether I multiply them first A and then B, or multiply them first B and then A, does not affect their answer. Like in addition, order does not affect the product when multiplying. That's what the commutative property is saying. And sure enough, we see that that is true. When multiplying integers, 1 times 2 will give us 2, and 2 times 1 will also give us 2. Order does not affect the product. And when dealing with positive and negative numbers, that property is still true. Order does not affect the product. A negative 1 times 2 will give us a negative 2. A positive 2 times a negative 1 will still give us a negative 2. Okay? Now let's move on to the associative property. Again, like in addition, in multiplication, because order does not matter, we can group our integers in any order we wish and still retain the same product. So the associative property is defined as saying that if A and B and C are all integers, then we can group the quantity of the product of A times B and then take that quantity and multiply it by C. And that total product will be equal to if we were to group the quantity of B times C first and multiply that quantity by A. As you can see it very clearly here in this example. If we are multiplying 2 times 3 times 2 and we decide to group the first two integers together, 2 times 3 gives us 6. We now take that and multiply it times the additional integer of 2. 6 times 2 is 12. If we choose to group them differently, again, this time we're going to group the middle 3 and the last 2. Okay, we'll group them together. So we have 2 times their quantity, which is 6. 2 times 6 is still 12. So you can see that the associative property and the commutative property kind of go hand in hand. So if you have one, you kind of have the other, right? All right, let's move on to the identity property. Now, this identity property is the same identity property that we have in multiplication when we're dealing with whole numbers and not integers. It still applies when we're multiplying with integers, but please note that it is different than the identity property in addition. So the identity property for addition is very different than the identity property for multiplication. In multiplication, the identity property is if A is an integer and 1 is a unique integer such that A times 1 will be equal to A, meaning in multiplication, the identity property is to multiply by 1. When doing so, you will not change the integer that you started with. Like in addition, the identity property is 0, because when you add 0 to any integer or whole number, it does not change it. So your answer, the sum, remains the same as what it was when we started. In multiplication, the identity property is 1. When you multiply 1 by any whole number or integer, then your product will remain the same as when you started. As you can clearly see here in these examples, these very simple examples that make it very clear, 3 times 1 is still 3. 5 times 1, still 5. 1 times 6, still 6. 1 times 7, still 7. And you can put in positive and negative numbers here as well. You can make the ones negative, and we're going to discuss that a little bit later. But you can make any of the non-1 integers here positive or negative, and the same would be true. If this was a negative 3 times 1, then our answer would be negative 3. If this was a 1 times a negative 6, then our answer would be negative 6. In a moment, we're going to address what happens when we make the 1 negative. You're going to see that in a moment. It's a bit of an extension of the identity property here in multiplication, particularly as it refers to integers, because that's where we can make the 1 negative, right? Okay, so if we move on to the next property, here is a property that up until now we have not discussed because it only applies when we're talking about multiplication. This is a unique property to multiplication. It is not found when we're dealing with addition, and it does not apply with division, but it does apply when we are talking about multiplication, and it's called the distributive property. It is a foundational property for multiplication. It's particularly a foundational property of multiplication when we move on into algebra, okay? So the distributive property says that if we let A and B and C all represent integers, then the following scenario is always true, and that is that if we take the quantity of the sum of B and C and multiply that by A, then that will be equal to if we took the product of A times B and the product of A times C and found the sum of them together, okay? In essence, we distributed the A across the sum and got rid of the parentheses along the way. So here is a concrete example of what we're talking about in the distributive property. If we have the quantity 3 plus 1, and that quantity is being multiplied by a 2, then according to PEMDAS, right, order of operations, we would do what's in the parentheses first, and that means we'd find the sum of 3 plus 1, which is 4. Then we could go ahead and do our multiplication, which is 2 times 4, and we get the answer of 8. But according to the distributive property, we could also take this 2 and distribute it across the sum and get rid of the parentheses, and we'd end up with 2 times the 3 plus 2 times the 1. And if we complete it on this side, according to PEMDAS, if this is what we're looking at, we are then going to go ahead and do the multiplications first. So 2 times 3 is 6, and 2 times 1 is 2. Now we can go ahead and do the sum. 6 plus 2 is 8. And look at that. They are both equal to 8. So that it proves the distributive property does indeed apply to multiplication. You can take something you're multiplying and distribute it across a sum, okay? Now, here is what I promised before about what happens if we make 1, which is the identity property of multiplication, and we make it negative because we're talking about integers, right? Well, what happens here is if we make the 1 negative, then whatever you multiply the negative 1 by will give you the negative reciprocal of what you started with. So it's a bit of a twist on the multiplication identity property. The identity property says any integer times 1 will still be that integer. But when we're talking about integers where we allow for negative numbers, then any integer being multiplied by a negative 1 will be the negative of what it started with, or rather the reciprocal. So if this was 2 times a negative 1, then our answer is negative 2. But if this was, let's say, negative 3 times a negative 1, then our answer would be positive 3, because the positive 3 would be the inverse or the reciprocal of the negative 3 we started with, okay? Now, let's talk about the cancellation property. This in particular applies because it's one of the rules that we use when solving equations, okay? The cancellation property says that if we let A, B, and C all represent integers where we are sure to make sure that C is not equal to 0, okay? So C can be any other integer, but not 0. Then the product of A times C will be equal to the product of B times C, and therefore, if we cancel out the C's, A has to be equal to B. Now, we use that rule when we apply it to things like this, where we say, for example, that the product of 3 times X is equal to the product of 3 times 2, okay? Well, we can cancel out the common integer, right? So say we cancel out the 3's, and we're left with X is then equal to 2. And sure enough, that is how we would go ahead and solve this kind of simple equation, right? And we do so by using the cancellation property of multiplication. All right, let's move on to division. As you know, all the rules that we discuss in division are in play, those basic rules I told you about. If we are talking about the same sign, meaning both integers are positive, then we know our answer, our quotient in division, will be positive. If we have both integers being negative, then we know that our quotient will still be positive. But if we have a division where the integers, one is positive and one is negative, then our quotient, the answer to our problem, will be negative, okay? And you can see here is how they like to explain it. They say, let A and B be integers so long as B is not equal to 0. Why? Because we don't divide by 0. Remember that that's undefined. That's why fractions, where you have a numerator over 0, is considered undefined. So we have to make that statement that we're not allowing for B to be equal to 0. Then we can say that A divided by B will be equal to some quotient C. However, this is only true if that means the opposite, that A has to be equal to the product of B and C, right? And you know that this is true. That's how we teach division. We teach it by having it be fact family with multiplication, much like how we teach subtraction and addition as fact families. So what we're basically saying here is that this division statement will stand and be true so long as it's part of the fact family where the product of the quotient plus one of the divisors is equal to the original quantity that was being divided, right? So you can see it here. We're basically saying that 12 divided by negative 3. Now here our signs are different, so our quotient will be negative. 12 divided by 3 is 4 because 12 is positive and 3 is negative. Two different signs, our answer is negative. So 12 divided by negative 3 is negative 4. And according to this will be true if, going in the opposite direction, the multiplication family member applies, right? So let's see if that's true. If we take negative 4 and we multiply it times negative 3, do we get back a positive 12? And sure enough, we do. Because if you remember the rules of multiplication, if they both have the same signs, in this case they're both negative, then their product will always be positive, right? So then we know that this division is true because it's part of this fact family, okay? All right, now let's talk about ordering integers. How do we determine which one's greater than, which one's less than? And it is a little funky when we start applying integers as part of our comparisons here, because normally we would say things like 5 is greater than 2. Why? Because the quantity 5 is more than the quantity 2. However, when we apply integers, there is a bit of a difference, and you have to follow the rule. This is the rule. And the best way to explain it is to explain it using the number line approach. We do have an additive approach, but I find that this one is usually the best one to introduce it, particularly to children, to make it concrete and clear to be understood. And this is what it is. Integer A will be less than integer B if integer A is also to the left of integer B on the number line. Why? Because on the number line where we include integers, if you recall from when we started this chapter, 0 is in the middle, and all the positive integers are on the right, and all the negative integers are on the left. So basically, if we were to start on the left over an infinity and start making our way towards the right over to positive infinity, as we do so, every number that's further to the left is less than the next number that brings it closer and closer to 0. The closer we get to 0 on the left-hand side, the bigger the number is becoming. Once we pass 0 and we move on to the positive side, then it's exactly as we expect it to be from when we learn counting numbers, right? And whole numbers. So if we are comparing, for example, -3 and a +1, because -3 is on the left of the 1, then by default, -3 is less than 1, okay? Because it's further to the left on the integer number line. Therefore, -3 is less than 1, okay? Now, there's another way to explain it, and it's called the addition approach. The addition approach says that integer a is going to be less than integer b if there is a positive integer p, such that if we add that positive integer p to a, together they will equal our original b. If that's the case, if there is a positive integer that we can add to our original a such that they will equal b, then we can say for sure that a is less than b, okay? Here's how they explain it. For example, if we are comparing -5 and -3, okay? They're both negative. Now on the number line approach, 5 would be further down to the left than -3. So using the number line approach, we would definitely say that -5 is less than -3. Using this addition approach, we would say, do I need to add, meaning going in the positive direction, do I need to add a positive integer to this -5 to get to -3? If so, then I have just confirmed that -5 is indeed less than 3. And you do have to do that. If we have a -5, we would have to add a positive 2 to get to -3. Therefore, we can say with certainty that -5 is indeed less than -3 by using the addition approach. But you can see how this would actually be a little more confusing to young children than using the number line approach. So my advice is that when you're introducing integers to your students, the number line approach is probably a better and more concrete way to help them understand this concept of how to determine whether or not a number is greater than or less than, okay? So finally, what if we're talking about integer a? All this time we've been saying a is less than b, but what if a is greater than b? Okay, well, the way you would prove that a is greater than b is that you would prove the opposite, that b is less than a, and then you're back to using the tests that we've just discussed as a way to prove that b is less than a. So that's basically how you prove that one is greater than the other. You prove the opposite. Okay, that's just math for you. Alrighty, now let's talk about the properties of what happens when we order integers, okay? There are a couple of properties that come into play when we're comparing integers. So let's talk about them. First of all, if we let a, b, and c be integers, we're gonna let p represent a positive integer, and we're gonna let n represent a negative integer. Then the following properties come into play. We have what's called the transitive property for less than, okay? Meaning this, if integer a is less than b, and we know that b, integer b, is less than c, then we can conclude by virtue of the transitive property of less than that a is less than c, okay? And let's look at it concretely. Sure enough, if 2 is less than 3, which it is, and 3 is less than 5, which it is, then it's safe to say that 2 is also less than 5, and it is. So the transitive property for less than applies, okay? Now let's look at the less than and addition property. This property says that if we have integer a and it is less than integer b, then if we take integer a and add some integer c to it, and we also add it to integer b, the sum of integer a plus c will still remain less than the sum of integer b plus c. Okay? Again, let's use some concrete numbers to show this. If we start with two integers, integer 2 and 3, and we say 2 is less than 3, then according to the addition property of less than, if I add the same integer to the 2 and to the 3, in this case I chose 1, then the sum of 2 plus 1, which is 3, and the sum of 3 plus 1, which is 4, will still be, the sum will still be less than the respective sum, as you can see here. So the sum of 2 plus 1, which is 3, is still less than the sum of 3 plus 1, which is 4. Okay? So everybody follow what I'm saying there? If you've got any questions, please feel free to ask me, okay? When you see me in person at the live on Friday or via email. Okay, now, we also have what's called the less than and multiplication by a positive property, okay? What that means is, if we have, for example, we're comparing a -2 to a +3, right? Because -2, and again, I really like that number line way of thinking about it. -2 is way further to the left on the number line than the 3, so I know -2 is less than 3, right? If -2 is less than 3, and then I choose to multiply -2 and 3 together, okay, that product will still be less than the one that was originally greater if I take it and multiply it by a positive number. I chose +1, but I could have chosen +2 or 3 or 4. It would have still been graded. If I had chosen +2, let's say, then I would have had -2 times 3, which is a -6, and I would have had a +3 times a +2, which would have been a +6, and a -6 would still be less than a +6, okay? So what we're saying here is, if we are comparing these two integers and the number that is already greater than gets multiplied by a positive number, it will be greater than the product of the original number that was less than if we take it and multiply it by the number it was being compared to, okay? The next thing we're talking about here is the less than and multiplication by a negative number property. What this says, okay, is that if I have 2 and we're saying it's less than 3, and then I multiply them by negative numbers. You see up here, the -2 got multiplied by the +3 that it was originally being compared to, right? And the 3 got multiplied by a positive number. Here, what if I multiply them by negative numbers, okay? So if I have 2 is less than 3, and I'm going to multiply 2 by a negative number, and I'm going to multiply 3 by that same negative number, then all of a sudden, my original number that was less than now is a negative number that is actually greater than my original number that was multiplied by a negative number. Okay? So, and you can see that because now -2 would be further to the right than -3 if we look at it on the number line. Okay? So what this is saying is my original numbers, if I multiply them both by the same negative number, it will automatically make my number that was less than will now become the larger number. And over here, what this is saying is if I take my two original numbers and multiply them by a positive number, both of them, then their relationship will stay the same. Okay? But here, these two are take my original numbers and multiply them each by the same negative number, their relationship will change. That's basically what those two are saying. All right, guys, that completes section 8.2 and therefore what we're going to discuss in chapter 8. So on Friday after our live, you will have a test to take. You will once again get a 2-hour window to take it in and make sure that you submit it on time so that you can get a proper grade for it, okay? The homework for this section is already up on this assignment as well as on your task bar on the home page. It's going to be found on page 329. You're going to do numbers 1 through 12. You're going to skip number 7. And for any number that has multiple parts, you're only going to do parts A through C. All right, guys, take care. I'm going to stop sharing my screen here, and I will see you guys live on Friday. Okay?